Okay, so let's get started. We're going to be taking a look at working with our math block feature found in our Link G5 and G4X programming. Our math blocks are something that we like to use to create either logging channels that are going to combine a couple different channels into one, or we can use it as a runtime value for programming purposes. So we might be configuring a condition for an output based on multiple conditions. It may be using a runtime value that we want to work in our table for programming. The math blocks allow us a huge flexibility in our Link software. So if you're familiar with doing any tuning with Motec M1, you're locked into the firmware and all the features that are in your specific firmware build. In order to have more features or functions, you either have to go to whoever wrote the firmware package and have them add a bunch of things in, or you're going to have to purchase a different firmware package that gives you, let's say, some different features or functions that you'd like to use with your Motec M1. The Link is essentially unrestricted. This gives us the ability, what would be the equivalent of a Motec M1, of a developer style license and developer style programming. So we can get super creative with the software and do almost anything we want. So the math blocks are something that I like to use. Now, there's so much we can do with them. I'm just going to scratch the surface here in this tutorial and just talk about some of the basics to get a feel for what we can accomplish with math blocks. Let's jump in here and take a look at setting up our first math block. And what we're going to do is create a custom channel called Lambda uncorrected. This is going to be useful to be able to run closed loop correction, but be able to strip away what the closed loop correction is applying to our Lambda reading, to our fueling value, and be able to see what that uncorrected value is so that we can use that for tuning purposes, specifically in our mixture map function. When we play back a data log, we can see what the mixture map is populating and showing. And by using a Lambda uncorrected channel, it allows the mixture map to function. We don't have to turn off the closed loop. We can't run mixture map with closed loop on, but we do want to always run closed loop on. There's no reason to turn it off. So this is where we can get creative using a math block to create a runtime channel for something like the mixture map to function and strip away the closed loop correction, but just doing this mathematically, not actually turning it off. So we're keeping our closed loop correction on, but we're creating a math channel that strips away the closed loop correction so that the mixture map can use the reading. So we can keep both in place at the same time. Let's take a look at this real quick. What we're going to do here is jump all the way over into our window, label virtual/math. In here, we find that we have our math blocks to program. Now, there's only 4 showing, but there's 8 total that we can program and work with. You can access the additional math block 5 through 8 going here to our ECU settings, looking in our math folder, and we can see we can access the other math blocks. If you need more than 4 math blocks, then you can go in here and grab some more and add some more into the screen. Now, the reason why I have things paired together in terms of timers, math blocks, virtual auxes, and general purpose outputs is because a lot of times we use the math blocks in general purpose programming working with virtual aux. So there is a lot of functionality in here, and that's why I've just paired everything here in one table and one page. Okay, so what we're going to do here is create our math block channel first. Then we're going to learn how we can integrate this to the mixture map. Again, so we can keep closed loop on and also populate and dial in our field table with the mixture map. So the first thing I'm going to do here is go to the label. I have to give it a custom label. And in here, I'm just going to call this Lambda uncorrected. So we'll say here Lambda and uncorrected. Okay. And then the next thing here, we have our parameter A, B, C, and D. And what we have to do is assign essentially a character. So our A character here, parameter A, what's what we put into the equation, we assign it to a channel or a runtime value here with the link. So my formula is going to be including closed loop field correction, closed loop Lambda long-term field correction, and then Lambda 1 value. That's what we're going to designate here for parameter A, B, and C. Then we'll write our equation down here so it can calculate that runtime channel. Let's go in here and start to create our equation here. So we're going to a parameter A, and then we're going to be typing in here CL field correction, so closed loop field correction. And we should find that populated here if we go down our list. So we want to have our closed loop Lambda field correction, click OK. Then we're going to go to our parameter B, and we're looking for our long-term correction. So we're going to type in here CL, closed loop, and we're going to go down here to the long-term option. So we're going to do closed loop, Lambda, long-term, LT correction, long-term correction. And then our last parameter here, parameter C, is going to be our Lambda 1. So we're going to type in here Lambda, and we're looking for specifically Lambda 1 channel. Now you may also have additional channels. Let's just say if you have a Lambda average, there's probably going to be a Lambda average in here. If you're looking at a banked engine, you have 2 Lambda sensors. You probably want to take the average. You probably want to go ahead and use that, but I'm going to use Lambda 1 here since I have a single Lambda sensor. So let's go ahead and click OK. Now, the decimal places, we'll use up to 3 decimal places. That's going to be just saying how many decimal places in the calculation we're going to carry forward in the math block function. And then the last thing here is writing the actual equation. So my equation is going to go A, so bracket, A plus B, and then it's going to be plus 100, bracket, and then /. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.